Good day, everyone. I am Ayana Angeline Sihuko, and I will be discussing the third types of mathematical models, which is the linear and nonlinear models. First is linear models. A linear model shows a situation when two variables change in a constant way and in a direct relationship to each other. The other variable responds in a constant and predictable pattern when the first variable changes. So this means that in a linear model, whenever one variable increases or decreases, the other variable also changes in a steady and consistent manner. The pattern is predictable and the rate of change does not vary. This is why linear models are often represented as a straight line in a graph. So this is an example of a linear models. So these graphs show how a straight line can describe a trend in the data. So in the first graph, the line slopes up, meaning that as one variable goes up, the other usually goes up too. So in the second graph, the line slopes down, meaning that when one variable increases, the other tends to decrease. So the red line is basically the best line that we can draw to show the overall pattern. Second is the nonlinear models. A nonlinear model is one that does not have a constant rate of change between the x and y variables. In a nonlinear model, as you manipulate one variable, it does not respond in a constant straight line manner. So in other words, nonlinear models describe relationships where the change is not uniform. When one variable changes, the other may increase or decrease at different rates. So this makes the pattern more complex, and it is usually represented as a curve rather than a straight line. So this graph shows a nonlinear relationship. This means a straight line can't describe the pattern in the data. Instead, the points curve upward, so the best fit line is curved. This tells us that as one variable increases, the other also increases, but not at a constant rate. So the relationship changes depending on where you are on the graph, which is why a straight line wouldn't work here.
Hi everyone, I'm Armin P. Arangco and I will discuss my part all about discrete and continuous model. So first, let's discuss the discrete model. A discrete model describes change that occur in separate distinct steps. The values involved are countable, such as whole numbers, people, objects, events, or anything measured at a specific interval. So ginagamit ito kapag ang data is collected periodically at hindi continuously. So, example, each day, hour, months, and year. Now, let's proceed importance in discrete model. First one is counting and categorization. Method of organizing data where counting determines the number of items or event and categorization groups them based on shared characteristic. For example, a teacher counts a student present in class and then categorize them by grade level or gender. Next one is simplicity and efficiency. So, easy to compute because the values are whole numbers. For example, ang teacher ay nag-record ng bilang ng mga student sa klase kada session. Sa halip na i-check bawat oras or segundo. So, next one is clear insights. Show how a quantity changes step by step. For example, a farmer counts the number of harvested crops each week, understanding growth pattern over time. Next is application. Useful in population counts, business sales, inventory, and event tracking. For example, is counting the number of people in a city during a census. So, for example, the discrete model is about population growth model, so counting the number of people each year. So, population growth model is a type of discrete model that measure how the number of people in population change from one year to the next. Since population is counted at a specific intervals, the data change in separate steps, not continuously. So, in this model, you can count the population at the end of each year and compare it with the previous year. This helps you whether the population is increasing, decreasing, or remaining at the same over time. The model is discrete because people are countable units. The population is measured at a specific time. or yearly, not every moment. So for formula for the discrete model is P sub n plus 1 equals population at step n. Next is P sub n plus 1 equals R times P sub n. So next is R equals the growth rate. The last is P sub n plus 1 equal the population at the next step. So next topic is all about continuous model. A continuous model represents change that happens smoothly and without interruption over time. Unlike discrete models, the value in a continuous model can be any real number including decimals, because the process is ongoing without no gaps. Continuous models are used when you need to track a phenomenon constantly, rather than specific intervals. So, this is the importance in continuous model. The first is precise measurement. It is a capture small or gradual change accurately. The next is smooth dynamics, shows continuous change has smooth curve rather than in steps. Third is analytical power, used for mathematical analysis, prediction, and understanding trends. The last one is application, widely used in science, engineering, biology, and physics. Example for continuous models, motion of car tracking speed at every moment. This motion of a car is an example of continuous model, which is speed and position can change at every instant, not just at specific times. Continuous model measure change smoothly over time, capturing all small variation in motion. Unlike discrete models, which is record data at separate steps, a continuous model gives a detailed accurate description of movement, showing exactly how speed increases or decreases or remains constant at any moment. Formula in continuous models. So, first is dp by dt equals kp, or the rate of change of p with respect to time equals k times p. Next is p of t equals p naught times e to the kt, or the value of p at time t equals the initial value p naught multiplied by e to the power of k times t. Variables pt is population or quantity at time t. P naught initial value or value at t equals 0. K is growth constant, t is time.
In conclusion, understanding the different types of mathematical models guide us in selecting the proper method while analyzing the problems facing the real world. Every model, deterministic, stochastic, linear, nonlinear, discrete, or continuous, presents its capabilities and strengths that let us, for instance, predict the future, interpret the data correctly, and come up with the best solution.